with the whole online thing. So it again got a little bit crazy. I guess I need to start sharing my screen here, don't I? Okay. So in that the mosaic plot got left skipped over again. So we got to skip over. We got to jump in there and talk about the mosaic plot, and then we need to talk about one of the normality inferences for two proportion z-test that changed that I forgot about until we got so I got through it and I saw some stuff in some teacher chat groups. So anyway, so the mosaic plot is what we had to talk about first. Okay, it's really it's going to be another side-by-side graph, very similar to the segmented bar graph. We focused a lot on the segmented bar graph in class, as far as a way to show different how different proportions of a population fit together. So what happens is we're essentially going to combine two segmented bar graphs. We're going to go in each direction. Okay, so if we look at the example that I have printed off here, let me see. Okay. That doesn't need to be, I don't know, how does that work? Well, we're going to put it over there. Yellowstone National Park surveyed a random sample of 1,526 winter visitors. They asked each whether he or she belonged to an environmental club like the Sierra Club. Respondents were also asked whether they own, rented, or had never used a snowmobile. Here's the two-way table summarizing the data. So what happens is we have different ways that we show categorical data. A bar graph is the most typical one. That's the one over here on the left, okay, or a side-by-side bar graph. So they have turned all of these into proportions so that we can see here from this that it looks like roughly 22% own a snowmobile. As far that they do, first of all, they do not belong to the environmental club, but 25% of them own a snowmobile. 40 of them rent a snowmobile, and 38% or so have never used a snowmobile. However, if they do belong to an environmental club, we see that owning the owning proportion is way down, that renting is down as well, and that never have used a snowmobile is way up. Okay, so we can see that those variables are not independent of each other. Okay, there's a relationship between those two. So if we were to throw that into a chi-squared independency test, we would see that it's um, not independent. Okay, what we did back in Unit 1 then was we took these little bars here and we created what's called a segmented bar graph. So we turned that into 100%. So we started with this 22% over here, and actually we started with the bottom, didn't we? Okay, so we started out with that 38. We added 38 and 40 together to get something around 78 up here, and then that means the other 22% then had to be for own. So we practiced that. We practiced turning something into a segmented bar graph. Again, it's another way of pictorially looking at, hey, there's a difference between these two groups. There's even a difference between these two groups, a little bit smaller, then there's a large difference between those two groups as far as owning. Okay, now the problem is if we come back to our graph here, or come back to the chart, we see that there were 1,200 respondents that do not belong to an environmental club. However, there's only 300 that belong to that do belong to the environmental club. So it's a little bit disproportionate. So essentially what happens is we're going to turn this into a two-way segmented bar graph. So what happens is now we're going to go with the environmental club membership. No represents about, let's see, do they actually give that to me? They don't. So this is why I need my calculator today. So if we take 1221 and we divide that by 1526, we get 80%. So we can basically, and it's not scaled at all, which is kind of a surprise to me, but over here, 80% of my x-axis is then encompassed by the no, I do not belong to an environmental club, while the other 20% of the x-axis is by yes. So that's what a mosaic graph does. It kind of goes in a two-way, so that way you can see as far as area proportion of all people, kind of allows us to get that observation. Okay. So an example here to answer questions. Body image A random body image, a random sample. I'm not sure. I guess I should have proofread. Of 1,200 U.S. college students who asked, "What is your perception of your own body? Do you feel that you are overweight, underweight, or about right?" The two-way table summarizes the data on perceived body image. So we have males and females in the perceived body image. Of the respondents who felt their body image was about right, what proportion was female? So this is actually a nice little review, again, of conditional probabilities. Okay, of the respondents who felt their body weight was right. Okay, so that means that that was about right. So now we're talking about 855 is going to be my denominator. What portion of them were female? That would be 560. So we need 560 divided by 855. So that turns out to be 0.655. Now, just as a nice general review, I wanted to actually write out the probability statement that we would written out when we saw this, okay? Of the responders who felt like their body weight was about right, what portion was female? So that's the part that I'd ask you to written. I would have asked you to write out. If we go back just again as a review of probability, this is going to be the intersection of female and about right divided by all the people that were about right. So if we come over here and look, 855 is going to be my about right. The intersection of about right and female is the 560. So again, there's two ways to get to there. This way is showing the notation. The other way is just general logic. Okay. Of the female respondents, what percent felt that their body weight was about right? Okay, so again, we are just going to flip that around because of the female respondents, what portion felt it was about right? So that means that we're going to have female in my denominator, 760. Oops, let's go ahead and put that in there. So this is going to be about right and female divided by female. So we're still talking about the same 560. However, this time we're going to divide by 760, the total of females. So let's get that. The mosaics plot shows the distribution of perceived body weight, body image by gender. Describe what this graph reveals about the association between the two variables for the 1,200 college students in the example. So again, if we look at this, we have 760 divided by 1,200. And so if we look at this, this means that 63% were female, and that means that 37% were male. And what are we looking for here? So it just says, describe what this graph reveals. I actually don't have an answer to this. I don't know what the author was saying. I stole this from another book. Any ideas? What do you think? The one that I see a large discrepancy in is we see the underweight. So we see that there's a larger proportion of males that consider themselves underweight as opposed to females. But I'm trying to figure out what exactly the mosaic plot is showing here. I guess we'll go there. I mean, obviously, of the 1,200 people, a larger proportion was female, but we'll just go with that. All right. So this is an activity stolen from another website. When the high school was built in 1969, the school needed to pick a mascot. The principal decided to have the students and teachers vote between three choices: Rams, Falcons, or Prairie Dogs. He took a random sample of students and a random sample of teachers. The results of the surveys are given in the table. So it wants us to create two bar graphs to use and display the results. Use three different colors for the bar graphs. Not that you guys can do that, but I can sure give it a try, I guess. But I will make sure I shade it in two different directions. All right, so we have for the Rams, we have 80. Can I drag that? Oh, I can drag that. Look at that. Okay, so oh, that's not okay. All right, learn new things every day. Okay, there we go. So I'm going to shade that like that. So I'll change that color to be a red for the Falcons. So it looks like that 10. Well, this will be easy enough. We have 10% for Falcons. What are you doing? What am I doing? Besides making this hard. Okay, we're done. So we'll go my strokes this way, and then the Prairie Dogs wasn't much better. Okay, I am getting too wrapped up in the little things here because I don't know why you didn't turn into a box. Okay, there we go. All right, so now let's go look at the. That was the teachers. Let's look at the students. So student-wise, let's go. I should have done each color. It said that 30% were for Rams. All right. I'll quit I'll just draw them in there. There we go. It was 60% for Falcons. And it was 10% for Prairie Dogs. Nobody wants to be the Prairie Dog. Okay. Now, if we look at our display, according to displays, which mascot has the most support? So looking at those two displays together, just looking at percentages, and if you put combined percentages of teachers and students together, what are we going to say? Which one has the most support? So we're all sleeping. We all don't care. I can see both. So if we look at the Rams, the combined student and teacher percentage is larger than the combined Falcons or Prairie Dogs. So, for example, if we added these together, we see that if we added the bar length, we have 110% for Rams, we have 70% for Falcons, and we have 20% for Prairie Dogs. So, again, if we add those percentages together, it looks like Rams is the winner. Okay, and if we go back to this one, you're looking at areas. So the largest proportion here, and actually So the largest proportion, if the largest chunk are females that feel about right. Sorry, I wasn't happy with that answer, and then I realized here's what we have. We can see that we have a nice little area principle that pops in there as far as since we're going two directions there, so we can visually see the largest chunk of all people are going to be female. I mean, I could have got that all. Could have got that from this chart as well. 560 is my largest number in that chart. So I don't know. We'll just roll with that. Okay. Upon hearing the results for the surveys, the students argued the decision was incorrect because 100 teachers had been surveyed and 500 students had been surveyed. Use this information to fill in the table. Okay, so that means that if we had, oh, that'll be easy for the teachers because we had 100 teachers. So that means that percentage-wise, if we come back up in here, 80 times 100 is going to be 80. 80 teachers, and that means that there were 10 and 10. Okay, the next one gets a little bit harder. We have 30% of 500. So that means for this slot right here, we have to take 30% of 500. So that means that that'll be 15, and we'll take off zeros. So that will be 150. And if we do the same thing for the other one, so this is going to be 300. Or since this one is twice the proportion, this one is 60%, we'll double the other 30 to get 300. And then this is going to be even less. It is going to be 50. Okay, so we end up getting 100 teachers in there. We end up getting 500 students in that row. So how many times more students were sampled than teachers? So that was simple enough. It's 5. How can we update the third graph to make an account for sample size with an adjusted graph? So here's what we're trying to do. Okay, if we come back over from this one, we can we could go ahead and make a segmented bar graph for teachers. So in a segmented bar graph, I'm going to undo that. I'm going to change my color to black so I have black bars. Okay, if I made a segmented bar graph for teachers, this is what it would look like. Okay, I would come in here at 80%. See, I'll just do this on all in black because I don't have a pencil, or this would look like on my paper. There's 80% for teachers, 80%, 80 and 90. So that means that this is going to be the prairie dog, falcons, excuse me, and then up here is the prairie dogs. Okay, that 3. However, then we know that the students was 5 times more. So that means if I did a student one next to it, we had 30% rams. So instead of doing one section of 30% rams, I'm actually going to have 1, 2, 3, 4, 5. So I did a horrible job there. I'm actually going to redo those because I'm sliding downhill. I slid downhill again, but I don't care anymore. Okay, so there's the 30% for. Which way did I go? See, why did I drew my slashes the wrong way? Oh well, crashing and burning bad here. Anyway, there's my teachers. I'm going to take my eraser and we're going to whip through here and erase all those and erase those in there because they need to go the other direction. So here we go. Okay. What was it? Falcons. So if I add 30 and 60 together, that means that we're going to run all the way up here for the Falcons. I'm going to slide downhill again. My God, it's horrible. Okay. Do not slide down hill. So I'm drawing this completely backwards. I should have drawn all 5 of my segmented bar graphs first. So I'm just gonna admit my, oh my gosh, okay. Stop. I have an eraser tool, use it. Okay, so here's what I should have done. I should have drawn 1, oh my God, it's horrible. 1, 2, 3, 4, and 5, and I drape downhill again. Okay, but anyway, we did it. At 30% is going to be the Rams. $30 and $60 add up to $90, so 90% up here is going to be Falcons. And that means that leaves us with the 10% Prairie Dogs. So that allows us then, again, to see proportionally wise, area wise, obviously, again, for my chart, I can see I had 300 people down here that wanted the Falcons, but we can see that this is my largest area up in here. Okay, so we have made an adjusted graph. What should they make the EK mascot? It should be the Falcons. More people. Let's see, that's 310. This is what, 230. This is going to be 60. More people chose the Falcons than the other mascots. Area in the plot is the largest. Okay. All right. So there's our check for understanding. So I'm going to let you do those 2 pages on your own. How are you on time? Actually, this will work out right for time. All right. So here's the, so that's the mosaic plot. I can't say there's a whole lot of meat and potatoes in the mosaic plot, because if you're given the table to go with it, you can easily tell by number count which group, which area is the largest. So, but the deal there was to understand the mosaic plot. The combined proportion, this is the part that we need to get, and we aren't gonna, I'm not gonna pound at this as far as going back and reviewing the entire test. The only difference about this is going to be, all it does is going to change our normality check. Okay, so when we went through this previously, I was looking for, we would look for successes and failures. All right, so in this case, we had 38 successes, and that means that if we did a similar, if I had 38 successes out of 62, that means that we had 24 failures. And then over here, I had 49 out of 61, so that means I had 12 failures for here. And that would have been enough to tell me that my sample size was large enough, we were approximately normal. However, since we are comparing P1 to P2, okay, if that is our assumption in the very beginning, that means that the proportion of successes and failures should be the same or among the groups, okay? So therefore, what we're going to do is we want a combined proportion of successes, okay? So in this particular case, okay, so I know I am going to, it's asking me, does this provide significant evidence? So it asked me a yes or no question. So I know this is going to be a 2 prop Z test, and everything is still going to move forward exactly the same as it has before. Okay, I know I can use my phantoms to do this. Okay, I can state my parameters, okay, where P1 is the true proportion of something. I haven't even read the question yet. In a study in Michigan, it was determined that 38 out of 62 poor children who attended preschool needed social services later in life, compared to 49 out of 61 poor children who did not attend preschool. Does this study have a significant difference? Okay, so P is a true proportion of poor children attending preschool needing social services later in life. And you know what? I went down the rabbit hole I said I wasn't going to go down. I said we were just worried about the normality check. But since I'm here, I thought we'd go through one test. All right. P2 is the true proportion not attending. Okay. And again, I guess I wanted to get there because my null hypothesis is going to be that P1 is equal to P2. My alternate hypothesis is that they're not equal to each other. Is that right? Does this provide that priest? No, okay. No. I am completely wrong here. So let's make sure we're paying attention to what we're doing here. Why am I completely wrong? Preschool reduces the need for social services later in life. So if that is true, if I'm going off my alternate hypothesis that it does provide, then that means that P1 is going to be less than P2. So that's what we needed to go back and do. Okay. So here it is. Okay. So here my assumptions. Actually, we'll do the whole thing. I'm just babbling now, but here we go. The assumptions. I should have a random sample. Boom, boom, doom, doom. Random sample of Michigan preschool students. Do I have that? I don't think it did. It just says in a study in Michigan. So we are going to PWC this. Okay, we don't have that. Okay, we can put an X out there. Approximately normal. So here's where things are going to change up. Okay, what I want to do then, instead of having a different proportion for each one, my assumption is, my null hypothesis is that proportion is going to be equal. So that means I'm going to add up all of my successes. So we're going to have a combined p hat. That combined p hat is going to be 38 plus 49 divided by 62 plus 61. And I don't have, that's a number I don't have. %. So what happens is, instead of taking n times, so my typical normality check is n times p is greater than or equal to 10. And n times 1 minus p1 is going to be greater than or equal to 10. That's my typical normality check. However, now my normality check becomes n times p hat combined. Okay, is greater than or equal to 10. And n 1 times 1 minus p hat combined. So all I did was turn it into a one large pool of successes instead of two individual successes. And then we'll also have n2 times p hat combined is greater than or equal to 10, and n2 times 1 minus p hat combined is greater than or equal to 10. So those are the four things I need to check. So now, is 70 times 62, is that greater than or equal to 10? And is 0.3 times 62 greater than or equal to 10? That's what I need to check. Okay, it is. Okay, in reality, all we have to do is check the smaller one. 0.3 times 62 is 18.6. So that checked out okay. Then I also have to take 0.7 times 61 and take 0.3 times 61. So it's a combined pool versus a singular pool. Okay, and if we get lost and you end up doing that instead, again, I just wanted us to, I didn't want some weird ticky-tacky thing to cause you to lose points. Okay, And if we can't remember to do the pooled one, it's not the end of the world. In reality, if we jump out here, so this is the other thing that we have to remember about this. If we come out to my calculator, not my calculator, I don't want my calculator. We're going to do this on my calculator. So we're going to go into stats, we're going to go over to test, and we're going to take that 2-prop z-test. So we're going to click option 6. Okay, clear that out. I still have, crap, I don't have a hard copy next to me. Anybody? So I'll flip back and forth. What do we have here? 38 out of 62. So we had 38 out of 62. And then we had 49 out of 61. We are testing left, and we're going to calculate that. So what happens is it gave me my critical value is a negative 2.32. I have a very small p-value. Okay, it gave me the proportions, but my result then is because my p-value is so small, we're going to reject my null hypothesis, and we're going to say that there is a difference between the two proportions of children needing social services later in life by that proportion is reduced by attending preschool. Okay, I was going to stop there. Okay, I feel like I'm killing too much time here. It was just, this is the concept that we need to understand. Okay, so we're going to do one more example and see if we can get this guy. Okay, well, I left 2 for you to do for homework. Okay, so let's talk, I'll just leave it as 1 then. Let's talk our way through this one. In 75, a random sample of 1,484 adult citizens were surveyed. 193 agreed that the statement people should take care of themselves. In 1991, 1,013 adult U.S. citizens showed that only 61 agreed with the statement. Does this indicate the proportion of U.S. citizens who strongly agree with this given statement has dropped? So again, this is a 2-prop z-test. Okay, I am doing my normality check, and I'm just going to stick with my normality check on this one. Okay, so number 1, is it a random sample? Okay. We have a random sample. We have, so random sample of U.S. citizens. That one checks out, okay? Approximately normal. So again, here is what is different. Typically, it was successes and failures greater than or equal to 10. Now we have to do a combined pool on a 2-prop z-test. So that means we had 193 successes. We had 1,000, nope. 61 successes. That's quite the change. So there we go. My sample sizes were 1,484 and 1,013. So there's what we're talking about. So 193 plus 61 divided by 1,484. So we ended up with 0.1017. So now in figuring this, now I have to take 0.1017 times 1,484. That should be greater than or equal to 10. Its complement is going to be 0.8983. That has to be greater than or equal to 10. And then we're going to go with 1017 again times my other sample size, which is 1013. That has to be greater than or equal to 10. And then 8983, this has to be greater than or equal to 10. So in reality, again, it's just checking the smaller one because then the larger one has to be true. So I am going to take in my head 0.1017. We're going to take that times 1013. And that ended up being 103. So that checked out. And if that one checks out, the rest of them are going to check out. So we don't actually have to show those numbers. Okay. All right. So that was the change we had to make. Now, I killed way too much time with this. I don't know how far we're going to get through the other one, but we'll give it a try. Okay. So the thing that I really wanted to get through today, I will hopefully we can get through it better, is a calculator function. So here's what we're at. This is actually so the other one will be an assignment as well. As far as you got to go ahead and answer those questions, and then do that one last normality check. We also have to do this one. We're going to go through this one, and hopefully I'll have everybody. We'll just go to like run out of the time or something here. But this is just an exercise in practicing the figuring out which calculator function you would use to solve this. Okay, so if we highlight here, for each of the problems, write the calculator function and the inputs. Okay, so those are the two things that we need to do that. So, but what I thought we'd do on this one, if I haven't put you all to sleep or everybody's off doing something else, is that we'll go through this and I'll make sure you have the right function, and then you have to go basically back and fill it out. But, my other option was just to let you have it. But let's read through the first one. The principal at North High School has considered a schedule change to have lunch earlier in the day. If more than 50% of the population supports that change, lunch will be moved. The principal took a random sample of 100 students and found that 54 supported the change. The principal conducts an appropriate significant test to see if there is convincing evidence that more than 50% of the population supports the change. Calculate the p-value for this test. All right, so in your calculator, what would you be doing? And so in the chat box, I want you to, so I can see, see how many people are getting engaged here, and B is to see how each of us are doing. What test? Okay, obviously it says we're going to do some type of test. Well, we're calculating a p-value for this test, so it said test. All right, so what are you going to run on your calculator? Okay, so either 4 people are actually engaged and the other 6 of us have just got it running in the background or something else. But here we go. We could go through our chart if we wanted to, but because this is a proportion, that proportion means that is going to be a z-test of some kind. Get out of here. So this is going to be why is my pen working? And because I only have the one proportion, this is going to be a one prop z-test. Okay, so now what happens is in the backside, you're going to go ahead and calculate the p-value, but you have to show me your inputs. Like for this one, the inputs will be your null proportion, your x, your n, and your greater than sign, and your p-value. Okay, so I want so that's all the things for question 1, but I don't want to take time to do this as you're doing it. Okay, you can come back and do this later. So number 2. Okay. A curious student wanted to determine if there was a difference in the average price of a quarter pounder in the United States and Japan. The student randomly selected 15 McDonald's restaurants in the United States and 10 McDonald's restaurants in Japan and recorded the prices of their quarter pounder hamburgers. Prices of the quarter pounder in Japan were converted to US dollars. The data summarized the test below. And I forgot, Ananya, you had the binomial CDF there. In a proportion actually can be done with a binomial CDF. So you would have gotten to an acceptable answer with that. Calculate a 99% confidence interval for the difference in the mean price for a quarter pounder hamburger in the United States versus Japan. So this is going to force you to go out. So again, this did not tell you, it's telling you to do the entire something here. I am not worried about doing the entire process. I just want you to tell me what calculator function will you use to get an answer, create this interval? What calculator operation would you choose? And then once you choose it, then it's showing me all the inputs and showing me the final answer. We are just going to go through and highlight all the operations first, and I'll let you do the other part later. So what calculator operation would this be? Okay, so then the only thing we got, we did pretty good there. This is a two sample T, but we have to remember that it's asking us to find a interval. So it's a two sample T interval would be the command that we would use. 3, the heights of all adult males in Croatia are approximately normally distributed with a mean of 180 and a standard deviation of 7. How tall must an adult in Croatia be in order to be in the tallest 5% of males? All right, so this is gonna have to dust off some cobwebs here. It's been a while since we did a problem like this. So what calculator operation is this? Okay. We are on the right lines with the people that are responding with normal CDF. That's along the right lines, but in a normal CDF, that's where we're going to start with a value of X and we're going to end up with a proportion. This is asking us to go the exact opposite direction. We're starting with a proportion. We're starting with the tallest 5%, and we're trying to get back to an X value of what height is that. So we do that with an inverse norm. So the inverse norm would have been the calculator. Yep, calculator operator there. Okay. 4. When playing the blackjack card game, multiple decks are used and reshuffled often so that the outcomes of the cards dealt are approximately independent. When a player receives two cards that they're a combination of an ace and a face card, this is called a natural blackjack, an automatic winner. A natural blackjack should occur 4.5% of rounds that are played. What is the probability that a player plays 20 rounds of blackjack and gets 3 or more natural blackjacks? And the key here is we are specifically playing 20 rounds. So because I'm specifically playing those 20 rounds, this is the binomial CDF. But remember that I'm wanting 3 or more. So that means I do not want those. So just to help us remember what we're going to do there. Okay. 5. The students in a statistics class want to estimate how many years it takes a university professor to earn a PhD. They survey a random sample of 40 professors with PhDs, which results in a sample mean of 5.4 years and a standard deviation of 1.6. Give the 95% confidence interval for the true mean number of years it takes a professor to earn a PhD. So what function on our calculator are we going to use to get that interval? Right. And the if we were in the process of naming that, again, it's not a name. When you're talking about one samples and T's, that's the we the that's not quite necessary to have the one sample in there. We just can call this a T interval and move on. Again, we are trying to construct an interval. Because it is a mean, it is 5.4 years. Because of that mean, um, that makes it a T interval. Okay. And since it's an unknown standard deviation, the standard deviation came from the sample. That's why it's going to be a T interval. So again, it's you just need to go back in and write me all of the inputs and give me the interval. All right, number 6. By one estimate, 3% of all Siberian Huskies are born with 2 different colored eyes. It's called heterochromia iridium. For a random sample of 100 Siberian Huskies, what is the probability that exactly 3 puppies are born with 2 different eye colors? Yep, I think we're all on the right. For those of us participating, all of us, I mean, we are on the right track. With the 100, we know that it's going to be a group of 100, so that means it's a binomial situation. Because it's a one exact probability, it is exactly 3. That means we're going to do a binomial PDF. Would be my calculator operation I got to take care of there. Okay. All right, electric vehicles make up about a very small population of the overall car market, but how much has that proportion increased? Independent surveys, a random sample of car dealerships that were completed, with 10 of the 10,000 cars sold in 2012 being electric vehicles and 100 of the 20,000 in 2016 sample being electric vehicles. Calculated 95% confidence interval for the change in the proportion of electric cars sold from 2012 to 2016. So again, if we say it's calculate an interval, so we need to know what operation on your calculator will you use to do this. Because it is a proportion, that means that we are going to use a z, and there are 2 proportions that I'm comparing, so this is a 2 prop z interval. Very good. All right, 8. This is a different type. This is one that we didn't hit a ton in class, if we even hit this one. So this will be a nice, see if we can know our calculator. No, and we did it. I know we did it on homework. According to the National Association of Colleges and Employers, the mean salary at a new college is 45,327. A small college wants to know if the mean salary of their most recent graduates is greater than that. A random sample of 10 recent graduates from a small college was selected, and the mean and standard deviation of the salary for those graduates found. With all conditions for inference met, a test statistic of 2.51 was calculated. What is the p-value for the test? So we're not actually going out and doing the test. They gave you the p-value. The p-value is 2.51. So now we have to figure out how we can change that p-value, how that test statistic into a p-value. Okay, and that's okay on this one. This one's a little bit of a reach. So the inverse t is going to give me a critical value for what we for if we are creating the interval. This is a p-value, so that means we need a probability, and we have an operation called a t-CDF, just like we had a binomial CDF and a geometric CDF. All those, if we go in our calculator and find that t-CDF, it will run all those together for us to get us a p value. All right, 9. A random sample of 95 vehicles is taken from a large parking lot in an office park. Below is the type of each vehicle and whether it's owned or leased by the driver. Oh, they did a owned or okay. Anyway, a chi-square test will be conducted to determine is there an association between the type of vehicle and the method of taming the vehicle as far as owned or leased, car, SUV, or truck. So it tells you chi-squared. So I guess you're telling me which chi-squared test are you going to run? Yes. This one will be an independence test. So this on our calculator, the calculator operation just is a chi-squared test. So there wasn't any type of drama to that, but we just know since this one is going to be we had to get that into our matrix, et cetera, and move on. All right, I'm going to move on. The scores on the verbal section of the GRE was approximately normally distributed, the mean of 150 and a standard deviation of 8.5. What is the probability that a random selected score on the verbal section is between 145 and 160? So just to go back and yes, the normal CDF is gonna be the right one for this one. Just to go back to the last one, since all those are direct messages to me. So on the AP exam, this is a case of well, because it said, is there an association? This is going to be a test of independence. So I saw a couple of homogeneities in there, just because on the way they asked the question. That's what forced that into independence. But remember, on your AP exam, just write that so we don't lose points for saying the wrong thing. Anyway, this one is our normal CDF. That's what we're going to use to that one. All right, 11. A bakery has 2 machines that proportion cookie dough into individual servings. The baker owner has concern that the machines are not dispensing proportions of the same size. To test this, he takes a random sample of 10 cookie dough portions from each machine, and the following results were obtained. He performs a significance test to determine whether the machines are dispensing different proportions of the cookie dough. Find the p-value for this test. Which test are you going to have to run on your calculator? Okay, because again, we are working with means. We have the mean size proportion distributed by machine A. Because they are means, this is going to be a t-test, and more specifically, my calculator operation will be the 2-sample t-test. All right, Home Alone series is a series, Christmas family comedy series created by John Hughes. There are 5 Home Alone movies. I did not know there were 5 of those. But anyway, below is the probability distribution of the number of Home Alone movies watched by a very large sample of high school students. Find the probability of watching watching 3 Home Alone movies and calculate the expected value. Ooh. What's our calculator operation for this, for an expected value? Now, granted, this one can be done by hand. If you don't remember the hand calculation, we're going to take the product of this plus the product of this, plus the product of this, plus this, and moving on all the way through. That's how we do the hand calculation. But I'm asking you if you remember how to do the calculator calculation of this, or what to do. Now, if depending on what it asked me to do, it's not necessarily a binomial thing because or a chi-squared test. It's not necessarily. Yes, this could be a chi-squared situation, but it's not. Just because that's not necessarily. It just wanted us to calculate an expected value. And what we're going to do there is we're going to put the outcomes into list 1. We're going to put the probabilities into list 2. And this is where we're going to run a 1 variable statistic on L1 comma L2. So that's what we're gonna have to do on that one. And that will give me a mean and a standard deviation for that. It's just one of the expected values. So that one had a different flavor to it. It's been, and again, it's been a long time since we did some of these. So that's why we're reviewing those. Mason never has a pencil when test day rolls around because the classmates are tired of having to supply Mason pencils. Only 15% of the students will give Mason a pencil when asked. Today is test day and Mason begins to randomly select students to ask for a pencil. Let Y be the number of students Mason asks until he finds someone who will give him a pencil. What's the probability that Mason gets a pencil by the third person asked? So because we're asking for success on the third person or by the third person, that means it could happen on the first, it could happen on the second, it could happen on the third. So that makes this a geometric model because it says by the third person, that makes it a CDF. Okay, if it's said on the third person, we would use a PDF, or we could, again, this is one where we can do a hand calculation and be fine, but that's all right. And our last one here is, according to the article in the africageographic.com, there are many unexpected uses for elephant waste. How much waste do elephants produce today? Well, studies show that the distribution of the amount of waste produced by elephants can be modeled by a normal distribution with a mean of 250 and a standard deviation of 21. What percent of an adult elephants produce at least 300 pounds a day? Correct. This is a normal CDF. The zoo has an agreement with the local farmers. They sell daily waste to the elephant farmer, daily waste for $5 a pound. If the amount of waste produced by an elephant on a given day is at the 10th percentile of the distribution of waste, how much money would the zoo make selling waste that day? So again, going back to A, it said what percent. So that means that we would need to have an operation that gives us a percent, which I guess could be a test because a p-value is a percent, but that's going to be our normal. Here we're starting with the 10th percentile, and we have to get back to a amount of waste. So that way we can take it times $5 to figure out how much we're going to earn. And yes, those of us that are answering with inverse norm, that is the correct calculator operation. So with that said, that completes that activity.